Hello. Hello, students. After we discussed the future value, now, we want to discuss the present value. In the real world, we run into a lot of present value issues. For example, you're dating a girl, and you are planning to get married 2 years later, when you graduate. So you want to have a wonderful wedding, yeah, and you have a you have a budget for your wedding. That is, let's say $50,000. Okay. Uh, Of course, currently, you don't have $50,000, but you can save an amount of money into your bank account so that 2 years later, when you get married, you have $50,000. Okay, and at your bank account, the interest rate is now, let's say, is 6.6%. Then you would like to ask yourself, how many dollars should you save into your bank account so that 2 years later you have $50,000 to have a wonderful wedding? Okay, so this is a present value issue. In this case, we know the future value, right? You have an investment in your bank account. Yeah, you expect to receive 50. You expect the value of your investment will be growing to $50,000 2 years from now, and you know the rate of return, or you know the interest rate on your bank account. Now you want to find out the present value. How many dollars do you have to save, or do you have to invest so that you have $50,000 2 years from now? All right. Okay. So now, this is the present value issue. Now let me share my slides with you. Okay. Uh, so in a sentence, personal value issue is, how much do you have to invest today so that you will have a target amount in the future? Because we know the future value formula. We know the future value formula, right? In the last section, we have learned the future value formula. In this formula, if we know the present value, if we know the rate of return of the growth rate, if we know the T, the number of periods of your investment process, then we can find out, we can calculate the future value. But right now, we know in the present value issue, now we know the future value. We know the R, we know the T. In this equation, the only unknown is the present value, PV. So we are going to solve this equation for PV. So this is a reverse process. of the present value. This is a reverse issue of the future value issue. Okay, and the solution is we are going to solve this equation for PV, because PV is the only unknown. PV is what we're looking for. Okay, and I think using small algebra, it is easy for us to find out the PV. Okay, now we have future value formula. Future value, this is known, equals PV is unknown plus 1 plus R raised to the power of t. Right, R and t are known. Okay, then in order to solve this equation for PV, we divide both sides by 1 plus R raised to the power of t. Okay, we divide the left-hand side by 1 plus R raised to the power of t. Then we have this one. Right, on the right-hand side, PV times 1 plus R raised to the power of t divided by 1 plus R raised to the power of t, and this 1 plus R raised to the power of t above cancel this 1 plus R raised to the power of t below, right? And then they cancel each other, and then on the right hand side we have PV. That is PV equals future value divided by 1 plus R raised to the power of t. Okay, so we call this the present value formula. With this formula, we can find out the present value. We refer this process of finding the present value of a future cash flow as the process of discounting. Okay, if we know the present value and we want to find out the future value, we call it the compounding, right? Compounding. And in the reverse, if we know the future value and we want to find out the present value, we call this process the discounting. Okay. In this case, the interest rate or R that we used is called the discount rate. Okay. So in finance, we usually say when we want to find out the present value of a future cash flow, we usually say that we discount a future cash flow into the present value. Okay. And now, let's look at again the present value formula. Okay, present value formula. It's like this, right? Present value, I rewrite this formula, then present value formula, PV equals FV divided by 1 plus R raised to the power of t. I can rewrite this formula as FV times 1 over 1 plus R raised to the power of t. Okay, for simplicity, I put this factor into a bracket. That is, now let's look at this. Now let's look at the content in this bracket. 1 over 1 plus R raised to the power of t. We call this the present value factor. Present value factor. What does this mean? It tells us the dollars needed to be invested today so that the investment grows to $1 in T years at a discounted rate of R. Okay. Now you have a investment process. Let's say that is T years or T periods. Okay, now you know, over this period, the rate of return is R. Okay, rate of return is R. Now, if you want to receive $1 in the future at the end of T period, then how many dollars should you invest today? That is 1 over 1 plus R raised to the power of T, right? Okay, so that is present value factor. Okay, now after we know the present value formula, we're going to use the present value formula to look at Raymond's gambling issue. Okay. Raymond's father, Raymond lost $2,300 in gambling to his father, Frank, right? And now Raymond's wife, Deborah, wanted Raymond to get the money back. Suppose Frank promises that Raymond will get $2,300 from his heritage, Then, do you think Deborah will be happy with this promise? Of course, we can say, this promise is a kind of agreement, between Frank and Raymond. Okay, so do you think Raymond's wife, Deborah, will be happy with this promise? Of course, we know, right? We know $1 today is more valuable than $1 you expect to receive in the future. The answer, of course, is no, right? Because $2,300 Raymond lost to his father in gambling is more valuable than $2,300 Raymond expects to receive from his father's inheritance. Okay. Now, under this background, now let's suppose if Frank passes away 10 years from the gambling, and the market interest rate is 10%, then by this agreement or by Frank's promise, how much does Raymond lose to his father in the gambling? Okay, suppose 10 years from now, Raymond can receive $2,300 from his father when his father passes away. Okay, and the market interest rate is 10%. That means this is an investment opportunity. Raymond can invest his money to earn the yearly interest rate 10%. Then in this case, how much does Raymond lose to his father in gambling? So this is the present value issue, right? We know the future value. We know the future value. 10 years from now, that is $2,300. We know the market interest rate, and then what is the present value? Okay, we can use a formula, right? We're going to look at this issue in this way. First of all, we find out the present value. Okay, we use the formula, find out the present value, and then I explain the meaning of the economic meaning of this present value. Okay, so first of all, let's use the formula. Present value equals future value. Present value equals future value. What is the future value? Future value is $2,300. Then divided by 1 plus R. R is 0.10, 10% in decimal, that is 0.1, and raised to the power. What is the power? Power is 10 years. Okay, Raymond will receive $2,300 10 years from now. Okay. If you do the calculation, if you can run your calculator correctly, I believe you can get the right answer. Okay, now I'm going to show you the right answer. And later on, I'm going to operate the calculator to get this answer. All right. So suppose you can operate your calculator correctly, then of course we can get this answer. So that is present value is $886.75. Okay, after we get this number, yeah, how can we understand this number? Okay, we can understand these results in this way. Let's say, Frank knew Deborah was not happy. Okay, and Frank told Raymond. Okay, all right. I'm going to give you $2,300 10 years from now. Okay. But I'm going to give you this amount of dollars in this way. Now, today, out of $2,300 that I win, I return you 800. I return you 800. I return you $886.75. Okay. However, there is a condition. After you receive this amount of dollars, you have to deposit this amount of dollars into a bank account immediately, and you keep your bank account for 10 years. And because we know, right, market interest rate is 10%, so you're going to earn 10% interest rate for 10 years. After 10 years, go to your bank. Then get all the dollars out. And Frank said, okay, I believe that is $2,300. So in this way, I return you, I give you back $2,300. Of course, we have learned that the future value, right? If Raymond received the money, $886.75, and if he deposited this amount of dollars into his bank and keep his bank account for 10 years, then we know 10 years later, he would receive $2,300, right? Okay. Then what does this mean? Then the present value of Frank's promise is worth $886.75. Okay, considering the Raymond just lost $2,300, then plus this promise, what is the net loss for Raymond? Of course, we're going to subtract the value of Frank's promise from the $2,300 that Raymond lost in the gambling. That is the net loss of Raymond, right? So in this case, we subtract $886.75 from $2,300. Okay, then we get $1,413.25. So that is the net loss. That is the net loss Raymond suffered in the gambling. Okay. Now we under this background, we're going to practice the second question. Okay, second question is the same. We are going to use the present value formula with different numbers. What if the market interest rate is 7% and Frank passes away 20 years later. Okay, in this case, the R and T have changed. Under this background, what is the present value of $2,300 that Raymond will receive, that Raymond expects to receive 20 years from now? Okay, and over the future 20 years, market interest rate is 7%. Of course, yeah, we can use formula, right? We can use formula. Okay, now, yeah, I'm going to show you how to use the formula. Okay, if we use a formula, of course, present value equals future value, $2,300 times the present value factor, right? What is the present value factor? Present value factor is 1 over 1 plus R. Yeah, in the second question, R is 7%. So in decimal, that is 0.07. Okay, and raised to the power is 20. Okay, that is the formula. Okay, now, yeah, we're going to operate a calculator. First of all, we're going to calculate the present value factor. After we get the present value factor, we multiply the present value factor by $2,300. Then we get the result, right? Okay, now I'm going to show you how to run the calculator to get the right answer, all right? Okay, where is my calculator? Here is my calculator. Okay, first of all, we are going to calculate the present value formula. In order to calculate, first of all, we calculate the present value factor. In order to calculate the present value factor, first of all, we calculate 1 plus 0.07 raised to the 20th power. Okay, so 1 plus 0.07 equals, of course, equals 1.07, right? And then, yeah, we're going to raise this base to the power of 20. What key should we use? Of course, we're going to use this key, right? And then we're going to use the number on the screen as base. And then we're going to input the power. Power is 20. What is this? This is the future value factor, right? This is the future value factor. After we get the future value factor, how can we get the present value factor? On the screen, yeah, you can find a key like this, 1 over x. That is a key. You can flip up a number on the screen, or you can get the reciprocal of a number on the screen. Okay, 1 over x. That means, yeah, we're going to do 1 divided by the number on the screen. 1 divided by the number on the screen is nothing but the present value formula, present value factor, right? So we're going to click 1 over x. Okay, then we get the present value formula. And then we multiply the present value formula by $2,300. That is present value, right? That is the present value. Okay. After we get the present value, so that means the francs, yeah, under this circumstance, the francs promise is worth $594.36. Okay, with this promise, how many dollars did Raymond lose to his father? Actually, of course, yeah, we're going to subtract this number. Yeah, we're going to subtract this number from the $2,300 that Raymond lost to his father in gambling today. Right? How can we do this? How can we do it? Okay. In this case, you should not write this number on your paper. You have to keep, yeah, because when you write this number on your paper, you would lose the accuracy. Okay. After, yeah, the calculator shows 6 decimal places. However, after these 6 decimal places, there are many decimal places. Okay, the calculator doesn't show that, but it is kept default. Okay, if you just write down this number, then you would lose the accuracy. So in order to keep the accuracy, okay, we just subtract this number on the screen from the $2,300. Okay, how can we do that? Yeah, I'm going to click this key, change the number, change the sign of the number on the screen. Okay, and then plus $2,300. Okay, and then what we have done is $2,300 minus, yeah, minus 500, yeah, 594.36, right? And then click equal sign. Then we get this number on the screen. That is the dollars Raymond actually lost to his father in the gambling, or the net loss that Raymond suffered in the gambling, right? Okay. So that so that is how can we get the number? How can we get the results using the formula? Yeah, using the formula. Of course, yeah, we can use a financial calculator. I'm going to use a financial calculator to do the second question to show you how to use financial calculator. All right. Again, yeah. When you begin a new calculation using time value function, you have to clear the memory. Okay, you have to clear the memory. So how can we clear the memory? We click this one, yeah, second, and then click FV. Okay, by doing this, we clear the memory. Okay, we clear the memory. Okay, and now, yeah, we're going to input the information that we know. What is N? Of course, N is 20, right? In the second question, N is 20 years. And what is I over Y? I over Y is 7. Okay, 7%. Be careful because we're using financial calculator, and the input of rate of return or interest rate should be in percentage. So that is 7. Okay, and present value, yeah, usually we define, yeah, usually we define the present value as a cash outflow, However, in this case, present value is what we're looking for, right? Present value is what we're looking for. So we skip this key. And the payment, yeah, if you are sure you have cleared the memory, then just skip it. If you are not sure, then you can assign the 0 to the payment. Anyway, for the time being, we don't use this key because we are dealing with a single cash flow issue. That means over our time, there is only one cash flow. Yeah, that is only one cash flow. And we want to find out the future value or present value of this cash flow. Then in this case, we don't have to use. Anyway, when we're dealing with a single cash flow issue, that means we're going to find out the present value or future value of a single cash flow. Then we don't have to use payment. PMT. And then in this case, what is the future value? Future value is $2,300. Right? Okay. As often, yeah, we define the future value as positive. Okay, as positive. Of course, it is up to you. You can define future value as negative. If you define future value as negative, then present value should be positive. Okay, yeah, we just follow the usual rule. We define the future value as positive. Okay, and now click future value. After we input the information, then we click compute, then click the present value. Okay, before I click the present value key, I want to ask you a question. After I click the T, what is the sign of the number on the screen? Of course, the sign, the number on the screen will show us the present value. Okay, however, it has a sign. It has a negative sign on the screen. Okay, here it has a negative sign. Okay, so that is how we can use a financial calculator to find out, to calculate the present value. Again, yeah, when you are using financial calculator, keep in mind, first of all, I over Y is should be in percentage. Okay, percentage in and percentage out. And FV and P present value and future value should be defined according to their direction, cash inflow or cash outflow. Usually, we define present value as cash outflow and future value as cash inflow. Okay, again, before you begin a new calculation, you should clear the memory of time value function. All right. Okay. So that is the example. Now let's let's go back to the slides. Okay. So here, yeah, this is the answer. Yeah, this is the answer in the first question, and this is the answer. These are the answer in the second question. Okay, exactly. Yeah, we get this number by calculation. All right. Now let's move on to the next slide. I think, yeah, because we have discussed how to use the financial calculator. Okay, we can skip this slide because this slide, yeah, illustrates how to use the financial calculator to get the present value. Okay. Now, let's look at the two important properties of a present value formula. Usually, yeah, also we can say, yeah, we usually, or also we say the important relationships in the present value formula. Okay. Property one, given an interest rate as well as the future value, the longer the holding time, the smaller the present value. Ceteris paribus. Ceteris paribus is a Latin. It means all else equal. I believe, yeah, it is easy for us to understand this property. Okay. The R is fixed, right? Yeah, we have a present value formula. Yeah, we have a present value formula. Okay, in this formula, R is fixed, and the future value is fixed. And now let's see, yeah, when T changes, how does the present value changes? Okay, when T changes, yeah, now let's see, when T increases, then we can see, yeah, 1 plus r raised to the power of t increases, right? Okay. And then when 1 plus r raised to the power of t increases, what would happen to the present value factor? That is the present value factor, right? Present value factor will go down. So yeah, we can conclude with all other things being equal, yeah, as t increases, present value decreases, or in the other words, we would like to say with all other things being equal, present value is inversely related to E. Okay, or yeah, simply speaking, yeah, as t increases, present value decreases. Okay, or vice versa, As t decreases, present value increases. All right, so that is the relationship 1. And now let's look at the relationship 2. Given the length of holding time as well as the future value, the higher interest rate, the smaller present value, series parables, with all other things being equal. Okay, now let's look at the present value. If v is fixed and t is fixed. Okay, when r increases, of course, 1 plus r increases, right? When 1 plus r increases, what would happen to the present value factor? The present value factor, oh, sorry, yeah, I missed t, yeah, 1 plus, yeah, when r increases, 1 plus r raised to the power of t increases, right? T is fixed. When r increases, 1 plus r raised to the power of t increases. Now let's look at, yeah, what would happen to the present value factor? 1 over 1 plus r raised to the power of t would decrease, right? Would decrease. Okay, then we can conclude, as r, yeah, with all other things being equal, or for a given t and fv, as r increases, present value decreases, and vice versa. So that is important relationship 2. And now, yeah, we're going to have we're going to look at a graph. With this graph, we're going to have a vivid understanding or impression about this future, these two present value properties. Now we have a graph. On this graph, the horizontal axis shows the holding period, or shows the time horizon. Okay. Now we can see, yeah, we suppose, yeah, we're going to hold a investment from time 0 to 10 years. Okay, to 10 years. And the vertical axis shows the present value of $1 to be received in the future over the horizon, over the timeline. Okay, well, again, vertical axis shows the present value of $1 that you expect to receive in the future. Okay, and then in this case, yeah, this graph shows how the present value of $1 to be received in the future changes as time horizon changes, given a series of interest rate, right? Given a series of interest rate. Now, for example, let's look at given a interest rate 5%. Now let's see how the present value of $1 to be received in the future as a holding period changes. Now we can see, right? You can see the present value would go down. Now we can see, right? The present value would go down. As your holding period gets longer and longer, the present value would be smaller and smaller. Okay, and yeah, usually I call this the present value profile. Okay, we call this curve the present value profile. Okay, now first of all, let's look at the property one, right? Property one, given a interest rate, okay, now we can see the present value of $1 you expect to receive in the future would become smaller and smaller as your holding period becomes longer and longer, right? That is property one. That is property one. And the property one is also good with a different interest rate or with a different rate of return. If your rate of return is 10%, you can look at this curve. You can look at the present value profile. Now you can see, right? It is the same thing. As you hold your investment longer and longer, in order to receive $1 in the future, then the present value or the dollars you should invest today becomes smaller and smaller. Becomes smaller and smaller. Okay, again, as you hold your investment longer and longer, in order to get $1 in the future, the present value or the dollars you should invest today becomes smaller and smaller. Okay, and this is the same for interest rate over 15% and for interest rate 20% and whatever interest rate this property holds. However, there is a special case. That is when R equals 0. Now we can see when R equals 0, then the present value profile is a horizontal straight line. What does this mean? That means when R equals 0, no matter how long you hold your investment, the initial dollars you invested does not change. Does not change. It is always $1. It is always down. It is always $1. It is always $1. It is easy to understand, right? When we know the R is the growth rate. If growth rate is 0, that means that there is no growth. So in the future, because over the investment process, there is no growth. So no matter how long you hold your investment, in the future, if you want to receive $1 today, you have to invest $1, right? Okay. Also, we can understand this point with math. Let's look at the present value formula. Present value equals future value divided by 1 plus R raised to the power of t. Now we know if R equals 0, then we have future value divided by 1 plus 0 raised to the power of t. 1 plus 0 is 1, right? Then the denominator is 1 raised to the power of t. So what is the value? 1 raised to the power of t. With the algebra, we know no matter what t is, 1 raised to the power of t is always equal to 1. So in this case, the denominator denominator is 1. So we have future value. So future present value always equal future value. Okay, now let's look at the second property. With holding period fixed, then the present value of $1 you expect to receive in the future would become larger. The present value would become smaller and smaller as interest rate becomes larger and larger. Right now, let's say, yeah, we are going to hold a investment for 5 years. At the end of the 5 years, you're going to receive $1. Okay, $1. Okay, now we can see, okay, if interest rate is 0, how many dollars do you have to invest today? That is $1. If interest rate is 5%, how many dollars do you have to invest at the beginning? At this level, right? Then approximately that is 80 cents. Okay, that means in order to receive $1 1 year from now, in order to receive $1 5 years from now, at the interest rate of 5%, today you have to invest approximately 80 cents, right? If interest rate is 10 cents, of course, yeah, we can find this point, right? This point, the height of this point represents the present value of $1 you expect to receive 5 years from now. I think that is 66 cents or so. Anyway, okay. Given 5 years, now we can see the present value goes down as the interest rate goes up. Right? As the interest rate becomes larger and larger, the present value becomes smaller and smaller. So that is the property 2 that we just learned. Okay, and this property applies to any other holding period. If we look at 8 years, if you hold your investment for 8 years, of course you can see, right, as the interest rate goes up from 0 to 5 to 10 to 15 to 20, the present value goes down from this level to this level to this level to this level to this level. Okay. Of course, yeah, before we move on, before we conclude, we have to pay attention to a special point. That is this point. At this point, what is the holding period? Holding period is 0. Holding period is 0. Now we can see, no matter what interest rate you would earn, if a holding period is 0, then the present value always equal to the future value. It is $1. Of course, we can understand this special point with economics. Because holding period is 0, so there is no time to grow, right? Then in this case, no matter what interest rate is, or no matter what the growth rate is, because there is no time to grow, then the present value equals future value. Okay, and of course we can understand this point with math. With the present value formula, present value equals future value divided by 1 plus r raised to the power of t. This time t is 0, right? Then we have fv divided by 1 plus r raised to the power of t. Now let's look at this term, 1 plus r raised to the power of t. T is 0, right? Yeah, because we are looking at this special case. There is no time to grow, so t is 0. In the algebra, we know, right? No matter what base is, if the power is 0, then this term is always equal to 1. Right? It's always equal to 1. Then, now let's go back to the present value formula, and we have future value divided by 1. Future value divided by 1 is a future value. So this is why present value is always equal to future value. Okay, no matter what interest rate is, if t equals 1, present value always equals future value. Okay, that is the present value. Yeah. Next time, yeah, we are going to discuss the applications of a future value formula. Okay, actually, until now, we know, right? Future value formula and the present value formula essentially is the same thing. Yeah, essentially is the same thing. Okay, so next time we are going to discuss how to use the future value formula or present value formula to solve the questions in the real world. All right, okay, that is all for today. Bye-bye.